Hi Math 2. This video is on solving radical functions. Radical functions would have a radical in them, and maybe it's a square root or a cubed root, and then this worksheet is how would we address those. So to solve an equation that contains a square root, remember we don't have an index number, you don't see a little 2 there, it's usually blank and we know it's a square root. We square both sides of our equation. If our equation has a cubed root symbol, then we cube both sides of our equation. So let's take an example of this square root number 3. So first off, before I can deal directly with the square root, I have this coefficient of 2 in front. So just like when we've solved for other variables, our first step is we need to isolate the radical. So in this case, I want to get that square root of x plus 1 alone on one side of the equation. In order to do that, I'm going to divide both sides by 2. When I divide this side by 2, my 2 cancels, and I'm left with the x plus 1. And 14 divided by 2 is 7. So now I want to solve for x, and the problem is it's underneath this radical. So I need to get rid of my radical. I need to cancel it. We can do that by squaring the left side of my equation. When I do that, by squaring the square root, they cancel each other out, and I'm left with just the x plus 1. I'm left with what was inside my radical. Now that my radical and my square, when I squared it, it canceled. So now if I've done that to the left side, I have to also do it to the right side. So when I do that and I square my 7, I get 49. So now I can solve for x. It's out from underneath the radical, and I can just use my algebra skills, subtract 1 from both sides, and I get x equals 48 for my answer. If I was concerned, if I made a mistake, I could plug this back into my equation. So let's take a look at another example. This example number 5 has 2 radicals in it, and those can be tricky, but the first thing that you need to do is you need to make number 5 look more like number 4. You need to move one of the radicals to the other side. You want to have a radical on the left side of your equal sign and a radical on the right side of your equal sign, and your math gets much more simple. So I'm going to add x plus 2, the square root of x plus 2, over to the other side, just like I'm adding a variable to both sides or a number to both sides. So this cancels on the left side, and I have the square root of 5x on the left. And on the right, I now have the square root of x plus 2. Now number 5 looks like number 4. I have a square root on both sides. These problems are actually very easy. When I go and do the step of squaring both sides, I have actually canceled both my square roots out when I do that step. So when I square the square root of 5x and I cancel the square root symbol, I get just the 5x. When I square the square root of x plus 2, my square root symbol cancels and I just get the x plus 2. And now I'm going to subtract x over to the left for x equals 2. I'm going to divide both sides by 4. I'm going to get x equals 1/2 or 0.5. What if it's a cubed root? So let's take a look at number 6. Number 6 is not a square root. I can see the 3 there. It's a cubed root. So just like number 3 above, I notice that my cubed root is not isolated. I'm going to isolate the radical first thing. So I'm going to divide both sides by 5. When I divide both sides by 5, this coefficient of 5 cancels, and I have the cubed root of 4x plus 3 on the left equals 3 on the right. So now I'm ready to solve this. I want to get to the 4x plus 3, but right now it's underneath the cubed root. So I need to cancel my cubed root. I can do that by cubing both sides. When I cube a cubed root, they cancel each other out. And I'm simply left with the 4x plus 3. And now be really careful. It's 3 cubed, not 3 squared. It's 3 times 3 times 3. So this would be equal to 27, not 9. That's sometimes a common mistake that happens when you are doing these types of problems. And so now I'm left with a linear equation I just need to solve for x. So let's subtract 3 over. I get 4x equals 24. Let's divide both sides by 4, and I get x equals 6. As you finish this worksheet, pay special attention to whether the problem has a cubed root or a square root, because that changes the math that you're going to do. Check your answers in the locker and bring your questions to Zoom. Thank you.